In this video, we'll take a look at cardinality. The cardinality is a count of the number of distinct elements within a set. Let's take a look at set A. There are 5 elements in set A, so the cardinality is 5. The notation for cardinality is 2 vertical lines on each side of the name of the set. This is similar to the notation used for absolute value. Now let's take a look at set B. In this case, set B contains 5 elements, but because the elements are duplicated, set B only has a cardinality of 2. Remember, the cardinality of a set is the number of distinct elements, so duplicates are not counted. Let's take a look at another example. In this case, we have 6 elements, but the cardinality is 5 because we don't count the duplicate B. Notice that we count the set containing 42 and the set containing X, Y, and Z, but we only count the set of X, Y, and Z once, even though it has 3 elements. Here's set D. In this case, set D has 2 elements: the empty set and a set containing the empty set. So the cardinality for set D is 2. Let's take a look at set E. Empty sets are tricky because while the empty set itself has a cardinality of 0 because it contains no elements, here we actually have a set that contains the empty set. Since a set is considered an element, the cardinality of E is actually 1. Remember, this notation refers to the empty set, while this notation actually refers to the set that contains the empty set. Now what about the cardinality of the union of sets A and B? To figure out the cardinality, let's first determine the union. In this case, the union of A and B is A, B, C, D, E, and F. So the cardinality of the union of B is 6. Remember, we don't count the duplicates. What about the intersection of A and B? Well, it looks like there's only one element that is shared by both sets, so the cardinality of the intersection of A and B is just 1. Here's a more abstract example. In this case, F is equal to n, such that n is an element of the set of integers. So what's the cardinality of F? Since the set of integers is infinite, the cardinality of F is also considered infinite. What about the set of all real numbers? As with the set of integers, the set of all real numbers has an infinite cardinality. Now, although both sets are infinite, the set of real numbers is considered to be much larger than the set of integers. This is because the set of integers only includes whole numbers. The spaces between each integer are not included in the set of integers, while the set of real numbers can be thought of as a continuous line that includes the fractional and irrational numbers that are in between the whole numbers. We can represent the set of integers in a set as we've done here. However, it's not so easy to represent the set of real numbers in the same manner. As a result, we say that the set of integers is countable, while the set of real numbers is considered to be uncountable. I should note that this is a somewhat simplified explanation of cardinality. In a more advanced discussion, there are actually different levels of infinity, but that's a bit beyond the scope of these videos.